So we're going to take a look at multiplying polynomials, which is the logical extension from multiplying monomials to a polynomial. And really, we're just looking at the distributive property here. So please put that back. If I'm looking at this, this is the most common way you're going to see multiplying polynomial. Now, a couple little definitions here. Polynomial, poly means many, nomial means terms. So this is a polynomial, and then this is a polynomial. And actually, these are a special kind of polynomials called binomials because you have two terms in the expression. So we're going to multiply two binomials, and you know that when you have something right next to each other in math, it means multiply. So that means we're going to have to multiply the f to everything in this binomial. So let's go ahead and do that. F times f is going to be f squared. F times 3 is positive 3f. Excuse me. Well, if we have to multiply the f to everything inside this binomial, then we're going to have to multiply this negative 5 to everything also. So let's do that. Negative 5 times f is going to be negative 5f. And notice how I've stacked the similar terms vertically so that I can add them later. Well then, negative 5 times 3 is going to be negative 15. Now, if you look at what I've drawn here, all of a sudden you see two binomials, and you see the proverbial rainbows and smiley faces. This is normally referred to as FOIL, first outside, inside, last. But I like rainbows and smiley faces because whenever you see a rainbow, it makes you smile. And just as long as you remember that these rainbows and smiley faces mean multiply, you're going to be in good shape. So once we've multiplied everything, we're going to add the similar terms. F squared has nothing similar, so we just end up with f squared. 3f minus 5s, f is going to be negative 2f. Because if I have 3 f's and I take 5 away, I have 2 negatives. Perfect. And I have nothing for this negative 15 to combine with, so this is what I've got. So if I multiply two binomials together, and the variables are the same, I'm going to end up with a trinomial. Tri meaning 3, 1, 2, 3, nomial meaning terms. Well, if I look at this problem right here, it is the same idea. If I wanted to, I could multiply it out horizontally, which is really the convention. And so I'd write it horizontally, and I know that many of you have already started doing this. And I could do my rainbows and smiley faces, or I could think of this as conventional multiplication, and I could multiply the 5 to both of these terms here. Negative 5 times negative 3k is going to be negative 15k. Negative 5 times 2k squared is going to be negative 10k squared. Well, I've multiplied that 5 times everything. Let's multiply the 4k squared. 4k squared times negative 3k is going to be negative 12k to the third. 4k squared times 2k squared is going to be 8k to the fourth. Well, now it's time to see if we have any similar terms. I have k to the fourth, k to the third, k to the second, and k. Are any of them the same? No. Can I combine them? No. So I am done. All right. Finally, the last type of problem that you may be seeing this week is multiplying a binomial with a trinomial. And the process is the same. It just means you have one extra multiplication, really. So let's go ahead and do our rainbows and smiley faces. 3x times 6x squared is going to be 18x to the third, because we add the exponents. 3x times negative 12xy is going to be negative 36x squared y. Negative 3x times 9y is going to be positive 27x y squared. Now it's time for the smiley faces. I'm going to switch to blue. Go Broncos. 4 times 6x squared is going to be 24x squared. Do I have any other x squareds? I don't. So 24x squared. Great. 4 times negative 12xy is going to be negative 48x squared negative 48xy. Do I have any other xy's? I don't. So I have negative 48xy, and then finally multiplying this out, and I don't have any other just plain y squareds. So I get plus 36y squared. And you really need to be careful and make sure that you have the same variables. So I'm going to do one more. I'm going to make it up off the cuff. Let's say we have, it's going to be very similar though, 3x plus 4 times 6x squared minus 12x plus 9. Let's do this again, because this way we're going to have some terms that we need to combine because they're similar. 3x times x squared, 6x squared, again is 18, and then we have x to the third. 3x times negative 12x is going to be negative 36x squared. 3x times 9 is going to be positive 27x. Well, now for our smiley faces, 4 times 6x squared is going to be 24x squared. And notice how I'm stacking the similar terms. 4 times negative 12x is going to be negative 48x. And then 4 times 9 is going to be positive 36. So let's combine the similar terms. Is anything similar with the x to the third? No. So we just bring it down. So we have 18x to the third. Negative 36 plus 12 is going to be negative 12x squared, and the variables remain the same, because if I have negative 36x squareds and I add 24x squareds to it, then I have negative 12x squareds remaining. Same thing here. So I'm going to have an x remaining, and so I'm going to write the 48 here, and I'm going to subtract, so we get 1. So we have negative 21x plus 36. And so there we have it, and we are done. So that is how we go about multiplying two polynomials together. Make sure you bring your notes to class, and I'll see you on Monday.